Hello. So it's data orchestration tools, is it? Today, we're going to take a look at the top 10 data orchestration tools in the space in 2026. Now, there's obviously a lot more out there, but these are some of the key competitors. And obviously, this isn't going to be exhaustive in terms of what they can and cannot do, or you'd be listening to me for hours. So we'll run through them, some pros, some cons of each one, particularly like the key ones. And hopefully by the end of this, you'll just have a bit of an idea of which is going to be best suited to your use case and reasons why or why you would not choose those for the set of tasks that you are looking to essentially run and manage from your orchestrator. So without that, let's get into the first one. Now, Orchestra is a relatively new orchestration platform compared to some of the other competitors, but hopefully that should give it a bit of an advantage when it comes to being familiar with current data tooling. So some of the good features of Orchestra include both a UI with a fairly healthy looking list of integrations to use out of the box that data professionals would again be familiar with. But in the background, it is declarative YAML again, so developers will be happy too because they can build the way they want to. On top of this, Orchestra also comes with a whole bunch of built-in observability, lineage, and cataloging that you may sometimes require other data tools for. And there's lots of kind of out-of-the-box features that may sometimes require you to go and buy more than just an orchestrator to fill in your platform. So in terms of setup, you may be getting off the ground a little quicker than buying 2 or 3 different tools or having to deploy one of your own. That said, that brings us to the downsides. There is no open source tier for Orchestra, though there is a fairly generous free tier available on their app. But it means you also cannot self-host some of the compute that you would with other tools. So for example, you can't run the orchestration layer on Kubernetes. And being a newer tool, there may also be a fair amount less community support than you will get from some tools like Airflow. But I guess the hope is that you don't need quite so much support because there is documentation and it's a newer tool. And as you can see from the homepage, it's fairly focused towards data professionals again, rather than being broadly available for literally anybody. So we have Dagster, who are one of the newer players in the orchestration space, but particularly designed around that for data teams. So some of their pros are they have a declarative framework that is asset driven, which means Dagster are more interested in the underlying data sets that you orchestrate rather than the pipelines necessarily. It's Python first, and that's very good for data teams as it's something they're pretty familiar with, and it means it's fairly extensible, along with a reasonable host of kind of expected connectors, though less than Airflow, but potentially more tailored to data professionals. And again, Dagster has built-in observability and lineage capabilities right there in its UI. Some of the downsides of Dagster include the steep learning curve that is associated with this asset-driven approach. It will take teams a little bit to adjust to that style of thinking and working. Again, there is some setup effort involved in deploying it if you're going for the open source version, or a cost associated if you're going for their premium Dagster Plus offering. Though, if you are to opt for this method, then the final con is some complexity in pricing, which has also changed recently. But this credit-based pricing approach means it's a little non-tangible compared to how you think about your compute. So that takes some adjustment as well. Keeping this going, next up is Prefect, who again are fairly popular in the data space. This is partly due to being also Python first, which allows them to be extensible, but also puts them right in the remit of what data people are used to. They also have a bunch of pre-built integrations. Again, you can recognize a lot of data tools in here, so an easy one to pick up for data teams. Other good features of Prefect are some of their kind of built-in durability functionality in their kind of Python SDK. They also facilitate hybrid and flexible execution for you to run your workloads wherever you want to run them. And they've released into their open source as well more event-driven triggers and capabilities. On the flip side, Prefect is probably less well known and less mature than some of the other tools, so there is a smaller ecosystem and not as much community support. On top of that, you either end up paying to deploy it with your kind of engineering capabilities and team, or you pay for the premium offering and have to pay that way. Finally, it is kind of reported that at scale, Prefect can become difficult to manage for lots of teams, but that's kind of based on their opinions. And up next, we have Orchestra, which is another platform that has both an open source and a premium paid offering that you could go for. Again, we have a whole host of pre-built connectors that look fairly familiar, if not potentially more than some of the other platforms. Some other pros of Orchestra include it's language agnostic, so you don't have to stick to just Python. There is lots of built-in event-driven functionality, and actually in the background, all of the pipelines are defined as YAML, which is pretty cool. But on the flip side, Orchestra has a lot of these features behind the paywall. So before you get carried away with the open source offering, please check out which bits you're going to need. This also means there is a much smaller open source community than there is for some of the other tools. So if you're looking for help, it's not as always easy to find. And you actually need to kind of care about your infrastructure as well as your jobs with Orchestra, which makes this a little more developer style of user focused than potentially the more user friendly UIs and setups of some of the other tools. Now, getting into some of the more specific orchestration styles, we have Databricks workflows, or I think they're called Lakeflow jobs now, where fairly obviously some of the pros of these are if you're using Databricks, it's right there ready for you, it's in platform, you can just access it immediately. This comes with the pro of it's super familiar for all of your existing users, adoption rate should be pretty quick, and you can onboard them and kind of get going very easily. And it has immediate access or potentially immediate access to everything within your data real estate already. So all your existing tools and connections and pipelines that you're running in Databricks, you can just start using straight away. Downside of Lakeflow jobs, the fairly obvious one, unless you're running Databricks, it's absolutely no use to you. On top of that, because of Databricks' pricing with serverless versus compute versus other things, it can get fairly complex to understand where your money is going. And it is just kind of part of their platform. So it's definitely not as feature rich as some of the other orchestrators. You may struggle to connect to external tools out of the box. You may not be able to do so many kind of cross dependencies and have some of the kind of nice things you get with all the other orchestrators. Following that theme of more built-in orchestration, we have Snowflake tasks. Now, when it comes to orchestrators, a lot of people probably won't even think about these, but you can use them to build out pretty complex DAGs within Snowflake if you want to. So again, like Databricks, this comes with the benefits of being in an existing platform, familiar to your existing users, therefore easy to onboard, and immediate access to everything you're doing in Snowflake, such as your data itself, your ML, and it'll keep it all there. It's not going to pull it out and charge you for the privilege. But the downsides are also fairly similar to they were with Databricks, where you're very locked into this platform. It's just for kind of within Snowflake, and if you don't have Snowflake already, it's no good to you. This also means it can be kind of hard to scale. There's not a lot of incentive for Snowflake to make this integrate nicely with lots of external tools. So you're probably going to be limited to running what you're running in Snowflake. And sometimes in the UI, especially even with Snowsite, the observability and kind of features that come with this orchestrator are a little lacking. So it's probably only good for more kind of simple data processing tasks that you do want to just keep within the warehouse. So what about this little guy? This is Flight. Now, Flight, again, is a Python-centric orchestrator, which means it's very good for onboarding existing data professionals, and they can write very custom things because of this. On top of this, Flight has a lot of kind of built-in resiliency features, and as well as very good dynamic workflow support, which make it very performant in running kind of large data workloads. You can spin them up and run them on very, very scalable infrastructure such as Kubernetes. But then that leads into the flip side, where having to run it on something like Kubernetes sometimes means this can be much more infrastructure heavy than some other tools. And as you've probably guessed by now, it's targeted at a fairly tech savvy group of people. You are probably expected to be a decent Python programmer and know all of the concepts around that, as well as what happens on the underlying infrastructure. This is particularly noticeable if you were to flick through their kind of integrations library, where you can see this is aimed very much at Python developers rather than people who are just familiar with the tools that they want to use. And finally, Flight have just released Flight 2. So I imagine there will be some kind of overlap crossover time where you haven't quite got everything you need on 2 and you might do on 1 or something like that. So it may be in a little bit of a weird place at this time. And now on to temporal. Now, temporal is a really interesting sounding orchestrator. So it comes with a whole bunch of pre-built SDKs that you can use to develop things. So it's multi-language by default, Python, Go, Ruby, pick which you're most comfortable with. And then from there, you get a load of resiliency features and highly scalable infrastructure you can use to run your workloads. But before we get too excited, Temporal is fairly clearly aimed at a more tech-savvy and developer-focused team rather than necessarily those who are just trying to string together some tools. I mean, if you look in their documentation, you can quite quickly see there's not really a UI in sight, even though one does exist. So to take advantage of these kind of resiliency and scalability features, there is a very steep learning curve associated with Temporal, and you will have to be quite tech-savvy to start in the first place. On top of that, there isn't really the kind of built-in integrations in the same way we have with the other tools. So going from naught to something is going to take a little longer than it is with some of the other orchestrators. And we are almost there. This is our penultimate orchestrator. So this is BMC's Control M. Now, Control M, you may not have even heard of, and there's probably going to be a reason for that. So Control M is a very sophisticated orchestrator, but it is essentially built for enterprises. So some of its cool functionality includes things like it very happily deals with both cloud and on-prem infrastructure very easily. It has very good SLA capabilities, as you would get in a large organization. And it has been around a long time, so it has been battle tested for decades and has been very resilient in that matter. It also has kind of built-in governance, so teams have been using it for a long time to look after their data and their kind of workflows. On the flip side, it's starting to look a little dated after all this time, so perhaps doesn't have the nice UI that some of the other tools do, and it actually does not have the same developer experience that you might expect from some of the others these days. So, nice CLIs or kind of Git flows or things like that. There is also a larger cost and kind of licensing associated with this than some of the other tools. So unless you're really willing to commit to this quite heavily, it may not be for you. And as with some of the more prolific enterprise tools, it can require a fairly sizable team to kind of manage this in the background because of all these extra capabilities in terms of SLAs and governance and on-prem and off-prem. It does take a fair team to actually manage Control M. But if it's for you, it's a good option. We have Apache Airflow, which is probably one of the most well-known orchestrators on the market. And that is partly because it has been around a long, long time. Now, some of the pros of using something like Airflow is that longevity means there is a large ecosystem of integrations that have been built over time, as well as a solid community to reach out for help. Some other pros of Airflow include its flexible execution. So you can run it on things like ECS or EKS or kind of push the compute to where you want it to run. And it's pretty vendor neutral in terms of what it integrates with. It's from the Apache Foundation, so it's not tied to a particular vendor. There's also a pretty comprehensive UI for observability that's been developed over time, which, love it or hate it, does contain a fair amount of information that you can use to monitor your pipelines and your general data stack. But what about cons of Airflow? Well, one of the main ones that's talked about is the difficulty in deploying it. It has several different disparate components that you need to deploy just to run one instance of Airflow. And, if you want to add things like environments or different domains for different teams, you need to spin these up over and over again, which has overhead, it has costs, and it requires somebody who knows how to do it. On top of this, the fact it's been built over a fair period of time means it's very feature rich, but that comes with a steep learning curve, for which there are some guides, but I think the overall consensus is that Airflow's docs are a little weak sometimes. And on top of that, being a older orchestrator, it was generally designed around more batch use cases than some of the streaming ones we get today. That said, it does still support it, but you can kind of feel it's been tacked on after the fact. Being Apache, Airflow is completely open source, but as mentioned, setting it up can take some time, which means there are lots of managed services out there for Airflow, including companies like Astronomer or Amazon's MWAA, which can take some time out of setting it up, but you're still going to have to pay somebody to manage it one day. And there we are, a quick overview of 10 of the best orchestrators out there in 2026. If you're looking for an orchestrator right now, go and try them. Go and access those free tiers, give them a go, and really see how they work for you before you just jump to the one that you've heard people use the most, because that may not be the best one out there these days, and you might find you're more suited to one of the others. So let me know how you get on, and thanks.